Julia meeting, Warsaw Julia meetup, and today I'm going to show you how to build your Julia computational environment in the cloud. So this will be a workshop on how to set up everything to get Julia working, and how to prepare the layout, how to configure the EC2 instances, how to set up and how to prepare your Julia environment at the AWS cloud. So the first question is, why the cloud? Why we want to run Julia in the cloud rather than on-premises computer? And for me, like we do computations here on daily basis, the main motivation is shorter time to obtain results. So instead of using, let's say, 10 servers for 10 hours, it's possible to use 400 servers for 15 minutes. This is the same result, but I can run a huge cluster in the cloud, and then I make my coffee, drink my coffee, and then my computational results are there. So this is the most important motivation for me to use Julia in the cloud. I can easily scale to whatever computational size I need, and in the result I can quickly do my analytics. Another issue related to that is the cost efficiency. So at AWS EC2 spot model, it's possible to run 1,000 servers, 1,000 cores for something like $7 an hour, which is basically very low price. It's even low compared to electricity costs. If I wanted to keep all the servers at my house, I would probably pay around about the same for electricity bill. Also in the cloud, I have very nice solutions for the computing clusters, and it's very easy to set up a computing cluster in the cloud. One product here on the list is the one that has been programmed by myself. If I need to make a cluster within 2 minutes, I have designed a very lightweight cluster solution called Kiss Cluster. And there is also a great tool from Amazon for very advanced clusters with full scale, with full-blown tools, and this is named CFN cluster, and this is also extremely usable and extremely comfortable to run simulations. So one thing, I have big access to any amount of computational infrastructure I need, and I have tools to manage all of these infrastructures. Last but not least, the data storage costs are also very low, and it's very easy to store any amount of data in the cloud. Okay, so what is the agenda for today's meeting? So first I'm going to look at Amazon EC2 instances from the perspective of computational scientists, that I'm going to tell you how I'm using those instances to perform computations. Next we are going to create an EC2 instance. EC2 stands for Elastic Computing Cloud, and EC2 instance in the cloud that is running Julia, and I'm going to tell you what are the options to configure Julia on such instance. I'm going to talk on how to build your own Julia machine, so how to build Julia on your own. Next, we look on how to configure an integrated desktop environment in the cloud. And here today we are going to consider two options. One is Julia Jupyter, and since in the cloud we are running in headless mode, headless means without any user interface. There are some small tricks about the configuration of Julia Jupyter, and I'm also going to show you how to configure Cloud9. Cloud9 is a free web browser based IDE that you can configure to work with Julia. Last but not least, I'm going to tell you some remarks about data storage and storing data on S3. So all of these slides have some parts of code, and all of this will be posted on the Meetup webpage, so you will have availability to use the code presented in the slides. So first, what are the EC2 instance types that we can use for computational science? So basically I'm using the instance types presented on the slides. So for testing or for playing with environments or for something small, I'm using T2 instances. Those T2 instances offer only a temporary amount of time large computing power, but they are not usable for running any long-time computations. But they are nice for playing with the stuff and for experimenting because their price is very low. Now we have C4 and C5 instances, and these are computationally intensive instances. They can come up to 36 CPU cores. And if I'm just going to run numerical simulations in Julia and I do not know what type of instance to use, this is my first choice. Now sometimes we run computations when we need to use plenty of memory, random access memory, and there are for this purpose there are R4 and X1 instances, and they can have up to 4 terabytes of memory. So they are really great tools for in-memory computing. Now there is an M instances that stands for intermediate instances, somewhere in between C and R, and there are GPU instances if we need to do GPU computing or deep learning. Another thing we'll need to know is Amazon machine image, and we are going to use an Amazon machine image with Julia. So basically, whenever you work on servers, you can pack up all the stuff into an AMI image, and then you can use this image to replicate the contents of your server in the cloud. Last but not least, in order to optimize costs, the best idea is to buy computational power on something called EC2 spot market, and this is actually the requirements if we want to have our costs very low. And for needs of computational science, it's usually the best option. More on that has been discussed or in a paper by me and Bogumił. It's easy to Google for it. Okay, so the first thing is about obtaining Julia for AWS. And we have basically 3 options on how to install Julia on an EC2 instance in the cloud. So the first option is to install from binaries. So there are binary releases of Julia and you can install it. You can build Julia yourself, so you can compile so you can compile it on your own, or you can use Julia Pro AMIs, and this is probably the simplest options.
And is there any difference in the end product of those 3 options?
Yes, I will talk about difference of the end product with the slide of Julia on options on how to compile Julia. Okay, there are tiny differences, but for most cases those differences can be actually neglected. I will elaborate on this more. Okay, so installing Julia from binaries, this is a set of commands, and if you follow this set of commands, you will have a binary version of Julia installed. All of the examples here are illustrated with Ubuntu because this is the most popular Linux distribution and it's most easily available. In a few minutes I'm going to show you where it is in the cloud. So this is the option 1. The option 2 is build it yourself, and basically the build process is the following. First, we need to install all the packages that are required to build Julia, and here they are on the list. Then we need to clone the source code from the Julia repository, so there's a command to clone. Then we move to the current Julia version. As of today, it's 0.6.2, so we check out the current version. And now we have 3 possibilities on how to build Julia, and it depends on our taste, and if you want to keep only with open source tools, or if we want also to use Intel compilers. Okay, so what are the options? So the options depend on what kind of mathematical libraries we are going to use. So the first option is to build Julia with OpenBLAS and OpenLibM, and this is the most straightforward option. I'm just executing I'm just executing the make command, being inside the Julia source folder, and then Julia gets built. As of today, with the current Ubuntu version in the cloud and with the current Julia version, it's all what is required. It's all what is required to build Julia, and I have my own custom built version of Julia. The second option is to include the Intel math kernel library, and basically after I fill in some forms at Intel website, Intel math kernel libraries are available for me for free, so I can install Intel math kernel libraries, and once I install them, I create a make.user file that is configured to use those libraries. So I add this information to the build configuration file. I execute a command that I execute a script that installs along with the Intel Mac kernel libraries, and then I can build my Julia. So if I'm using any ready Julia version, usually this is what I get. So if, for example, I'm using Julia Pro, it has been built with Intel math kernel libraries, but without Intel libm. So Intel libm is for the highest computational performance. So this contains some additional computational libraries designed specifically for Intel processors. And the point is that those libraries, libm, are normally a paid version. So I can get, working at a university, I can get them for free. I had to fill in a special form at Intel's website that I agree to use those libraries for non-commercial purposes and so on. And then if I fill in this information, then I can use those libraries. But if I'm a commercial company, basically I have to pay for them. So those libraries are, because in order to obtain those libraries, I need to install on my machine a full set of Intel compilers. So I need to install a full set of Intel compilers, because this is the only way to obtain libm, and this full set of Intel compilers is a paid product if I'm outside of academia. If I'm within academia, it's free. So in this way, I can customize my image, I can customize my build with those libraries. Also, there is one more thing. When I'm building it myself, you need to be careful about what instance type you use to build your Julia, and then what instance type you use to run on Julia, because the default make options use very aggressive optimization of the code to the current hardware architecture. And for example, if I'm moving away from, let's say, C4 2x large instance to C4.8x large instance on EC2, actually the instance architecture is changing, and the code will not work. So you need to be careful about on what instance you are building your Julia and on what instance you are using Julia.
But on the other hand, essentially I understand that building it yourself gives you maximum performance on your given hardware.
Exactly, yes. If you build it for yourself and you know what hardware we are going to use, you get the maximum performance. And it's also possible to create your own AMI with various flavors of Julia for various instance types at EC2, and then you can get most of the computational environment you have. So, and basically the build process is not very complicated. It's just about running those commands, and then it just builds. So you can easily build many versions like for each EC2 instance, and this is the most you can get out of Julia. Especially if you use also those Intel libraries. Also, it's possible to use Intel compilers, but it's not recommended on Julia forums. You use rather GCC compilers, but but you use this lib library. So all this code has been tested against the current Julia version.
Do you have any benchmarks how much performance, just more or less, you can get out by using?
So I tried with simple code, and the difference was negligible. So the benchmarks have to be specially designed for the functionalities coming from those libraries, and I assume, Bogomir, this is something we plan to do. We have not done it yet.
Okay.
Okay, so because it's actually quite interesting how much performance I'm getting when I'm using just the most typical version. When I would say the most typical version is just to use Julia Pro, and we will look at this Julia Pro in a minute because it's the simplest option. So there is Julia Pro. I can start Julia Pro and then I'm done. Okay. So now let us spin up a Julia along with Julia Pro. So here I am I am in my EC2 account. Among many available services, I have selected EC2 because this is what we are going to use today. So I'm clicking at EC2, and now I can launch a new instance that will have a Julia installed inside. And this is available at community AMIs, and I'm searching here for Julia Pro, and I'm selecting the one from the top of list. So it's Julia Pro installed with Ubuntu. Probably there might be in future some changes on how those images are distributed, and maybe there will be some links on Julia website. I think it's quite likely to happen soon. But now simply the only option is to search for Julia Pro, and here I have the latest version of Julia Pro image. So I'm selecting the image, and now I need to select on what instance type I want to use, and I'm going to run it on C4 large instance type. Let's assume this is the most comfortable option. So this instance has 2 cores, and it has almost 4 GB of RAM. I click next. I use all the default settings. I could buy this instance on the spot to save the price. So the regular price is 10 cents per hour, and the spot price would be 2 cents per hour. So I could save 80% of the cost running it as a spot. But there are disadvantages that Amazon can take away the spot instance from me anytime. On the conditions on how spot prices are fluctuating. For this demo, I will be not using it, but I'm using it very regularly whenever I run production computations and a large-scale computation. I run them on spot instances. Next, I click storage. So this image is packed on 8 GB, and this is, so for many scenarios it's okay. Sometimes if I do some computing, I need more storage space. So here, just for example, I have selected 12 GB. I click next. Now here are the network settings for this instance, and this settings means that anyone from the internet can connect via SSH. And actually these are not the most secure settings. Actually I should limit this to my IP address. But I'm going to present you how to use Julia with Cloud9, and currently Cloud9 is a very new product from Amazon, and Cloud9 documentation so far as of today does not have documentation on how to limit the range of IP addresses to such instance. So now for the time being I'm just making that possible to SSH to this instance for everyone. Of course, as long as SSH is secure, no one can get through this barrier. But for production environments, and it will probably change very soon. We should limit the amount of IP addresses that can access this instance. So maybe for scientific computing it's not such a big issue, but for corporate computing these are the things to care about. Next, I click review and launch. So I have here some information that my security is open to the world. So this is exactly what I have been talking about. But for Cloud9 there is no good manual at this moment of time how to what IP addresses I can limit it. And now I'm pressing launch. So I'm pressing launch. Now I need to select the key that I'm going to use to connect to my instance. And I have prepared some key previously, so I will use it. I could of course select create a new key and create a new key pair. So I click launch the instance, and now my Julia Pro instance in the cloud has been started. I have clicked on this instance. Now I can see that the status of this EC2 instance is pending. What it means that in few minutes it should come to life. And it should become available for my computations. Okay, here it is. So now we have a server that's running Julia. So let's see if it's actually Julia is there. Okay, so I'm going to SSH. I'm going to SSH to this instance. So the username is Ubuntu, and here is the instance name that I have copied. And once I SSH, the first time it's asking me if I'm sure about the fingerprint. It's possible to check it on EC2 instance website. What is the fingerprint of this instance? And now I'm logged in, and if I look inside this folder, here is the Julia Pro, and in Julia Pro folder there is the Julia executable, and I can use it to run Julia. And this is as easy as that, so there was lots of talking but not much to be run. Okay, and here Julia is now running, so this is the latest version as of today. 0.6.2, and I can check how it has been compiled. So if I run version info command, you can see that it includes Intel math kernel libraries, but it includes open version of libm. It has not been compiled with the libm that is provided with Intel compilers. So this is the version. This is the version we get by default, and also it's compiled in such way that it works on all EC2 instances. So it has not been custom made to a particular instance type. So if I'm compiling myself, I can get the most of all I can get. I can aggressively optimize for a specific instance type. So these are small details, but nevertheless they are here. Okay, so now so I have a Julia set up in the cloud. So now I need to set up some kind of programming environment. So let me exit it for a minute. So I need to set up some programming environment. And I have the following options. I can of course program inside terminal, and if somebody likes it and likes programming in textual mode, there are many editors that can be customized to be used with Julia, and it's quite easy to find information how to do it. Now the two options that we are going now to, so I get this with operating system. So the two options that we are now going to check are the following. We'll configure Jupyter Notebook with Julia, and we are going to configure Cloud9 with Julia. So these are the two options to be done. One command that we might want to execute after Julia is installed is to make a link to Julia, so we can just type on the console Julia, and it's also easier for this configuration and for Cloud9 configuration. So this is the first thing we want to do. Now the second step here is to open and tune out connection to our Julia installation. And the third step is to run the notebook. So let me come back to console. So in my last comment, I can see that my Julia Pro is here in this location, and normally I would every time need to give the full path, and basically this is not very convenient. So I'm going to create the link, the soft link. I'm going to create the soft link to my Julia. So this is my full folder to my Julia installation, and the link location, I will just copy it from the slide so I do not make a typo. So the link location should point to USR local bin Julia, and if I execute this command now, anytime I just run Julia, my Julia is starting. So this is a kind of post-installation step. Now, in order to run Julia and in order to connect to Julia, I can use Jupyter, and if I'm using Julia Pro, the Jupyter should be available. Let's see if it's here. At the folder local bin Jupyter notebook. Okay, I can run a notebook in this way. Now I can see here that here is the path that I should be using to connect. But this server is in the cloud and I'm in my local computer. So what options I have for connections? So one option, of course, would be to open this port, but this is very unsecure because it's not encrypted connection. So rather than that, I need to set up an SSH tunnel. So I'm going to kill this. So I pressed Ctrl+C to kill it, and I'm going to open connection again that will set up the SSH tunnel. So in order to set up an SSH tunnel, there is option -al 1888, because this was the port that it's been used. 121.0.0.1.888. Okay, and now I have opened a connection with an SSH tunnel. So now if I start the notebook, I can connect to it via my local web browser. So let me copy it to my local web browser. So this connection is tunneling, it was being tunneled via my SSH session to the server in the cloud. So actually, here we can see the Julia Pro folder, and let me create a new Julia session. Okay, so I'm launching a Julia session on the server, and if I'm going to type version info, then actually we can see that this is exactly the Julia. It's running on Linux machine in the cloud, and this is a notebook, so I can do it whatever I want with a notebook. Now this connection is secure because notebook is using SSH as a tunnel to the server, so this is a proper great security, and this is the first way to configure the Julia environment, and now I can be working with an IDE with a server that is located in the cloud. So this is the option number 1. And now let us move to the option number 2, which is slightly more tricky. So the option number 2 is to set up Cloud9 for Julia. And there are a few commands that we need to execute in order to set up Cloud9. So Cloud9 is a very nice environment from Amazon.
Just a question. Who has ever used Cloud9? So maybe, Przemek, you can just say a few words in general and show it.
Yes, I will show it as soon as I set up it. Okay, so I want to show it on this server that exactly we have here. So this is an IDE environment that runs inside a web browser. So let me take a place and let me first install the dependencies. So here is my server in the cloud. I'm going to now to stop Jupyter Notebook. I will just shut it down here, so I'm not getting some kind of error. So I'll leave the page. This is the kind of errors: connection refused if you kill your Jupyter and the page is being notebook web page is being opened. Okay, so let me do it. So I'm running the first command sudo apt update. So this is the first command to be run, and now I need to run the second command, which installs me Node.js, and it does not have to be any kind of the latest version. I can use an older version, and this is the easiest one to install. Okay, so something something didn't work for me. Let me try to reboot this instance. It should work. I think that some actions with package manager have not been finished. Okay, and let me now try to connect again, maybe this time without the tunnel. So let's see if it's going to start. It's not connecting yet, probably it's still rebooting. Let me do it again. Okay, I have logged in, sudo apt update. Okay, and sudo apt installed Node.js legacy free. Yeah, too much paste. Oh, this is bad. Does anyone have an idea how to reset?
Checking the internet, what you have to add to.
Yes, I've been installing it yesterday on the same machine, and it just went. Oh, maybe the free. Oh yeah, so there was a typo. Okay, so it's probably free got accidentally to the slide, and I forgot. Okay, so there was the typo. So it's what is required to install is Node.js legacy. Okay, so it's Node.js legacy, not Node.js legacy free. Okay, so it has installed. So again, it was sudo apt install Node.js legacy. So accidentally I have pasted too much. Okay, so now this has been installed, and now let me move forward. Now once we have installed, we can now spin up Cloud9. So among many AWS services, now I'm going to select Cloud9. Okay, so I have selected the Cloud9 service, and here I have a button, create environment. So I click create environment. I need to name somehow this environment. So let me name it Julia Demo 1. You can give some description, does not matter. I click next. Now I can either launch a new instance, but if I use a new instance with Cloud9, then obviously I would to go through all of the pain of, maybe not pain, but all of the work of building Julia, which basically takes like half an hour or even more. So rather than that, I'm going to connect to my Julia Pro. And now in order to connect to Julia Pro, I need to provide the following information. So the first one is of course the username, and the username is here, Ubuntu. Now the next piece of information I need to provide is the address. So let me provide here the host. Now here we have the port number, and last but not least, Cloud9 will connect. Cloud9 will connect to my EC2 instance. So I need to find, in order to do it, Cloud9 needs to be authorized to open this connection. So in order to do so, here is the public key of Cloud9. Now I'm going to copy it to my. Now I'm going to copy it to my clipboard. Oh, here's the button, copy key to clipboard. So I have copied it, and now I need to add. I need to now add this information to my users file. So let me just paste it to a command, echo. Now there is all of this command. It's somehow copied with an end of line in the end. So now let me go again to this command. So there is echo command, and to the echo command I have pasted the entire key that I have copied from Amazon website. And now I'm going to add it to the file name ssh/authorized users. So here it's here it says to add it to the file, and here this is the name of the file, ssh authorized keys. And once it's added to the file ssh authorized keys, so now I executed the command, it has been added. I can even show this file, ssh authorized key. So it's the third line. So here it's more nicely formatted. So it's the first line from Cloud9. It has been added, and now this key will be used by Cloud9 to connect to my server. Okay, great. So I managed to configure it. So now I can click next step. So I'm clicking next step, and here's the button, create environment. Okay, so let me create the environment. So now the Cloud9 is connecting to my server, and I get the question, can we quickly set up Cloud9 on your environment? And I click next. I could install it myself, so there are installation scripts, but I just let the browser to install all the software on my server. So I'm clicking next. So what will be installed? I just took choosing the defaults. And now, once I've clicked next, Cloud9 IDE is being installed on my EC2 instances. So all the packages or the stuff that is there will be installed. And I know it takes around 2 minutes. So I think it's and the environment is coming to the live. So what you can see here on the left, so this will be a classic IDE, something similar to like RStudio, running in the browser. So on the left I have files, folders, and so on. Here is the welcome screen when I will be editing my code, and here at the bottom I get the console. And the nice thing about this console is this does not require to have an SSH network access configured within my network. So for example, if I'm in a university that denies SSH access, I can still use Cloud9 because Cloud9 tunnels SSH connection via HTTPS, and in this way I can circumvent restrictions with regard to SSH. So it takes some time to install, but it's not very long. So very soon we should be able to use this environment. So now it's being set up. So the detailed instructions on how I did it, they are all in the slides. And once this environment will be set up, we will need to configure a Julia runner, because by the default it has runners for many languages such as C, C++, Go, Java, Python, but it does not have a runner for Julia, and we will need to configure it. So let's see if it's already running. Okay, installation completed. I click next, finish. Okay, and this is my programming environment in the cloud. Right? So let me try to use it. In order to be able to use it in any way, let me create let me create some file. So file.gl, save. So let me put some instructions. Okay, and maybe version info. Okay, and now we want to configure a runner that if I click run, it's going to run this file. I have few options to work with this. So the first nice option is I have here a bash shell, and like I have told you, even I can run this bash shell even if I'm in place that only allows network connection. So this bash shell is being tuned via HTTP network, and this is my Julia, and this is my Julia Pro installation. So of course I can start working with Julia through this shell. Very nice functionality that is available here is that this whole environment can be shared for collaborative work. So here is the collaborative button. Okay, I don't know why I'm now not seeing.
Maybe you have to share first.
Oh, share. Okay.
You may invite me.
Okay, I could try to invite. Actually, with my own account, it's possible to share. So basically, what gets shared? One is collaborative editing of source code. So each share account sees exactly the same screen, and many people can edit the same source code. But it's also sharing of the console. So the console is also interactive, and so I can type in the console, and the person sitting at the other computer is going to see what I'm typing, seeing the results, or two people can type in the same console. So actually, it's possible to share it totally interactively, like we have in Google Docs. You know, everybody has used Google Docs, so many people can use it at once, and this mechanism is really great. Okay, so let me configure the runner. So I'm creating Julia, a run configuration, and here is the new run configuration. Sorry, not this Julia. Run with, sorry, not run configuration, but new runner. Julia and run with new runner. So here is the new runner. It's showing me some default runner configuration, but I'm going to use the one that I have prepared in the slide. So here is my runner configuration. Now I'm going to copy it. So again, all is available in the slides. So I'm going to copy it here. Okay, and my runner configuration has been copied. Now I need to save it, and probably the most desirable name is Julia. Okay, so this is my Julia runner. Now I click save, and my Julia runner has been created. And now if I press this run button, then Julia is being run, and here are okay, I tried to run Julia run because I forgot to close this file, so I closed this file. Of course, it does not make sense to make a runner for julia.run. Let me do it again. So I'm here with my file version info, and now I press run. So the file that is currently selected is being run. So now my file.gl has been run, and you can see my program is running, and it's already integrated in this environment. So this is currently how you set up this ED for Julia. The main problem I have personally with this environment, I'm not able to send a single line to console. I've searched throughout all of the documentation and seems like there is no such functionality, and probably it's time to submit some ticket or some comment to Amazon.
But I understand that you can copy paste to the terminal emulator.
Yes, of course it's possible to copy paste to terminal. Of course it's possible to copy paste to terminal emulator, and it works like a charm. About sharing, I think this link at the top should work for sharing. Let me check if it's going to work. So it will go direct me to the login page, which is always complicated because I have set up full security for my account, and this is the way to do it. Because your AWS account is like your bank account. This is one-time password, so you can see it only once.
Or use it only
Use
once.
it only once, yes. Okay, and look, here is the environment. And in this environment, if I'm going to execute some very complicated Julia code, it should be visible in the other. Okay, so now my terminal is detached. So for the time of execution, the terminal is detaching. But now I click OK. I can see what the other user has executed in the console. Also, if I'm going to type here, it's also, it lost focus, but it should be also visible at the other, maybe I have not saved it. Okay, I need to accept collaborative mode. Okay, yes, it came here. So there is some delay, but basically if two people edit it, then the one person can see what the other person is doing at such collaborative code editing is possible. Okay, so this is as far as Cloud9 is concerned, and I've shown you how to configure it. Now, how much time we got? Because last but not least is how to configure the data storage place for your EC2 instance. So when we are doing our computations, any EC2 instance needs to be treated like something ephemeral, that it comes and goes, and basically I don't care about having instance, then dumping it, creating new instance, and so on. So rather, an EC2 instance is not very best place to store any data. Also, EC2 instance it's lots of configuration in have many of them. For example, when one EC2 instance share data with the others. Of course, it's all possible, but it's not very comfortable. Much better service for distributed file storage and maybe for storage that all of the instances have access to is by using S3 containers that are named buckets. How are any of you familiar with this technology? Okay, so I'm going. Okay, yes, Bogumił, yes, you are. I'm going to show you how to configure it. Okay, so this is the best place to store your computational results in the cloud. Data is always assigned to a specific region, so there are many regions in the AWS cloud, and the data is always there. And we can access directly those data via the command line. So in order to access it, the easiest way and the most comfortable is configure something that is named role. And now configuration of a role is, it could be easier, I could say this. It's not very complicated, but it's somehow difficult, because I need to create a role and I need to attach a policy to the role. So I first need to create a policy, and then I create a role and attach policy to the role. And here is the example of typical policy that I'm using whenever I'm storing some analytical data in the cloud. So this is very useful example. The only thing you need to change is the underlined this green code, because here you need to put your bucket name. So before the lecture I have created a bucket name that is named Shuffle-Julia, and now in order to configure access to this bucket, I copy this policy, and if you get the slide you can do the same, but you will have to use your own policies. So I copied the policy, and you can do the same. So let me go to my security credentials. So I'm here at my security credentials screen. Now what I'm going to do, I'm going to create a new policy. So here I'm clicking create policy. Here I'm selecting JSON. I'm pasting this JSON from the slide. I have exactly bucket with this name, but of course you need to update your bucket name. Remember to do it twice, so one here at the top and the second time at the bottom. So you need to update the bucket name. So this is the policy information. I click review policy, and now I need to give a name for this policy. So I call it, let me name this policy Julia Demo. So now this policy has a name, and I click create policy. Now policy defines a set of rights. So in order to be able to apply this set of rights to an EC2 instance, rather to some users, I need to create something that is called role. So now I click create role button. And there are many roles that can be created, but I want an EC2 role. So this EC2 role will enable me to attach policy to an EC2 instance. So I select EC2. There are again many options, EC2, and this is always what I use for my computations. Next. Here I need to find the policy that I just created. So its name was Julia Demo. So I click this policy name Julia Demo. I click next, and there must be some role, and let me call it Julia Demo role. So a role again has a name. So quite lots of clicking and typing, and now the role is created. So the role is created. Now I'm going back to my EC2 instance, and now my EC2 instance, which is this one, my EC2 instance, I want it to have access to my S3 bucket. So in order to do this, so just to recall that my S3 bucket was named Shuffle-Julia. Okay, so in order to do this, I have here attach or replace IAM role. I need to type in the name of the role. So here is the name, Julia Demo role, and I click apply. And once I clicked apply, this EC2 instance has an access to S3 bucket, and whatever process is running on this EC2 instance, it will have access to S3 bucket. So here is the bucket. So bucket is an infinite data storage, and there is any amount of data I can put inside this S3 bucket. Okay. So when we started our Jupyter notebook, a notebook file has been created. So maybe we could, for example, try to upload this file to S3 bucket, just to show you how the API works. So in order to do so, the first thing we need to do is to install AWS command line interface that is currently not installed on the Julia Pro AMI, probably will be installed in the future. So I click yes. And now this AWS command line interface got installed. So it's AWS command line interface. So this was the command, standard installation command. Okay, it has been installed. So just to recall, the name of was iTitled notebook. So let me try to copy it. So I'm typing AWS. Now I need to provide the region name. So this is a regional service. I'm working here in the Ohio region, and the Ohio region, the The formal name is US East 2. Now I need to select the AWS service I want to interact with, and this is S3 because this is where is the data. Now there is a comment, and there are comments such as, for example, ls. It stands for list files. It won't be very interesting because it's an empty bucket, but let's see if I can connect. Okay, there was something. Okay, double R. Okay, so let me type it again. Okay, it's empty. It did not do anything, but it also did not throw any error, which is good. If I want to, for example, if I want to copy a file to this bucket, instead of ls, it's cp, like copy, and of course you have move, and there's a parameter recursive for moving all of the files, and so on. So this is easy to use. And here is the name of my file, and here is the location that I want to copy it. And if I click enter, the file has been uploaded to my S3 bucket. And let's see if it's actually here. Okay, so you can see this file is my S3 bucket. And of course, this S3 bucket is accessible from all other EC2 instances that will have the same role assigned. And in this way, for example, typical scenario is to create a large cluster of EC2 instances, and they have all access to the same S3 bucket, and then if I run computation, that can use it to get the data for computations, or they save computation data to the S3 bucket. So this is a typical command and a typical scenario on how to organize it. Sample comments are there on the slide, so everything is described if you want to try it on your own. So to conclude, what we get here, we get very powerful computing environment, and it scales to our needs, and this is something I really like about using EC2 with Julia. I can select how much servers I want or how big they should be, and every time my computational results get ready before my coffee gets cold. So this is a big advantage. I can select hardware. I can also easily stop a server and change hardware within minutes. So if I'm doing testing and configuration, I usually do it on small server. Then suddenly I need to run full-blown simulations. Then I change the server that has like 128 cores, and I perform my computation. Also, it's very easy to create my own AMI. So I've used Amazon AMI. But for example, if I'm working in a team and I want to share a server with the other, it's just one click. I will show it at the end. Cloud9 enables collaborative work, so many people can work on the same piece of source code. And last but not least, Cloud9 is also free, so Amazon is giving it you for free, provided that you use it on EC2 instances. So for this nice user interface, you do not pay an extra price. Last but not least, if I have my server and I'm happy with what it contains, I could go to my server. I want to share it with the others. So I think it's there. I think it's the second one. Yes, I can right click on the server, and here I have a button create image. So in this way I can save my server as an AMI for later use, or maybe for large scale application. For example, I have run all of the Julia configuration and it has installed all the libraries I need, and then I want to use that pre-configured environment many times or share it with other. You can name it my Julia AMI, and I can reuse it many times. So that's all for today. Thank you very much for coming to this meeting.
Thank you for watching. If you would like to see more materials on Julia programming, please subscribe and visit our meetup website. You will find our contact information in the description.